So yeah, we can show the screen. This is my company is called Theoretica Applied Physics, and today we're demonstrating a new product called BACCH-DrC squared, or DrC2. It's a desktop audio system. We call it the 3D audio desktop renderer. My company is known for creating these processors called BACCH-SP. The BACCH-SP, as you see right here, is a high-end processor that it comes with a DAC or without a DAC that you use to turn your stereo system into a 3D audio system that will allow you to hear your stereo recordings unfold in 3D by allowing you to hear the 3D cues that exist in all stereo recordings. There's been a lot on the web, been a lot of reviews and magazines, and so you can learn about this on the web a lot, and it's won many awards over the past few years. But this year we decided not to bring the BACCH-SP here. There's one dealer in the building that has a BACCH-SP, he's using it for his showroom. But we are unveiling a new product. This is our first time we release a speaker-based system with such a low footprint that it can go on a desktop. So it's a desktop system, and it's been developed as a collaboration with a very special engineer whom I admire a lot. He and I teamed up about 4 years ago. His name is Dr. C. His name is Dr. College. He goes by Dr. C. He's the co-founder and CTO of Odyssey, the headphones company. So he holds a lot of patents on these transducers, planar magnetic transducers, developed originally for headphones. About 5 years ago, a friend of mine connected me with him and gave me a present, which is the early version of these speakers. And these speakers are very unique in the sense they can produce have a very fast impulse response. Since then, we have been working on this project that we finished only about a week ago. And now we have a product, and it's all branded, and it's all ready for sale. And this is the first demo of it, starting this Friday. Excuse me. So this DrC, we call it DrC squared, after him and me. And on the hardware side, what's most special is this transducer. This transducer is unique of its kind. It's the fastest speaker on earth in the sense that the response is incredibly accurate and fast. This is because it holds many records. One of the records it has the thinnest membrane ever made. It's less than 2 micron thick. It's made out of a proprietary aerospace material that's formed cryogenically at about minus 290 degrees. Minus 196 degrees C. And that membrane is then etched with a laser and then produce and embedded in a magnetic field with a heavy earth magnet that gives you an induction field that is record 1.8 Tesla. This is a huge magnetic field, which is pretty incredible for a transducer. The next record after that is 0.8 Tesla. So what that allows you is to have a very precise membrane excursion. And you can see it right here in the animation of it, that you can see there's only travel up and down. There are no transfer modes being excited. There are no breakup modes in the plane of the transducer. So no tonal distortion due to the transducer motion. It's a very pure linear transducer motion. And that also, because of the high magnetic field, the impulse response is almost perfect. So you get like a Dirac delta, basically. The whole thing moves with a less than 10 microseconds.
That's a pretty clear waterfall.
Yes, very much so, yes. So the bottom line, what you get is an impulse response that's magnificent, and a fixed response that goes from 50 kilohertz down to about 100 hertz. We go to 170 hertz, and then we cross over to a subwoofer, which is pretty incredible to get it from a single transducer and have it at such a distance from you, because this is originally headphones. So you'll see the technology that went to it to make it a speaker is pretty impressive, because you get to have full SPL, full sound pressure level at you, more than 100 dB at you from a meter and a half. You can actually use them as regular speakers if you want. The other special thing is the subwoofer. This is the first stereo subwoofer of its kind. It's a left and right subwoofer. It doesn't mix. It doesn't mix down to mono. So, and it's crossed over in such a way that when you go down to the lower frequency, the image stays in front of you as you'll see with our BACCH filter, makes it three-dimensional and stays in front of you. You are not aware of the subwoofer being under you. The other thing, the whole thing is run by our software, the BACCH for Mac software, which is a product we've been selling for the past several years. We have more than 500 customers who use BACCH for Mac. But when BACCH for Mac is integrated with this desktop system and then allows you to calibrate it once and for all, there are these two microphones that come with the product. These are scientific microphones that we make ourselves, and a lot of companies and universities use them for research. But every BACCH for Mac that we ship and every BACCH-SP that we ship come with this in-ear microphones. You put these microphones inside your ears once and for all, and you do a calibration. You don't have to do it again unless you change your speakers or your location in the room. And then you push on the button here, arm, and fire, right here. You click on the word arm here, and that will arm the system. And it will be asked to move your head to 3 different positions. You'll hear that sweep. I'm not actually making a measurement right now, but I'm just showing you what happens. And then it takes about 2 minutes, and then you produce a BACCH filter. The system produces a BACCH filter and a room correction filter together. So now, if you go to bin number 1, where we made this measurement before, you'll see the room correction filter is correcting the room. Without the correction, you get that phantom plot right here, the shadow plot right there. That's the room response, of these speakers' response in this room. And at high frequency, by the way, this is measured inside your ear. This is why you have these notches. It's called the pinna notches.
Right.
These speakers don't need much correction in high frequency because they're beaming directly. They're not interacting with much. And by the way, they're dipoles, so that everything is being canceled in the plane right here because of the back wave. So the reflection, there's very little, much less energy coming off the table because of the null here, the dipole null. Okay. But there's still some energy is reflecting from the screen. Because of that, you're going to get some departure from flatness. Because these are going to be used with screens, it's essential that you use room correction, our room correction software called ORC, Optimal Room Correction. You end up with a very flat response, all the way to about 40 hertz and down to 30 hertz. And that is essential to get the best sound from a frequency point of view. Plus the outstanding time response give you something quite special, I think. I'll let you judge. So the other thing we do, that room correction and the BACCH filter are head tracked. And they are done at your ear location. And as you move your head, both the room correction and the BACCH filter, which does the imaging, are updated in real time. Okay. So you're going to hear seamless audio as you move your head right and left. So let's go ahead and play a few things. Because of the small footprint, a lot of people are going to be tempted to play movies with this. And this is, I'll start with some movie demos. And then it shines mostly with music, of course, but it's pretty spectacular with movies. I'm going to play movies. Right now, I'm going to be doing a 2-channel down mix of these Dolby Atmos movies. Okay. But we have a technology coming soon that will actually emulate very accurately 12 speakers around you from 2 speakers. But we're not going to talk about it today. We're going to use just the stereo. Everything you're going to hear is regular stereo. Great.